Crypto 2, Electric Boogaloo. So I guess we can introduce ourselves because we are recording this and the people in the recording will not have the benefit of looking at the screen to see who is talking. So my name is David. I'm hosting the space. That's my claim to fame. With me is Thomas.
Hi, I'm Thomas.
He's sorted out his mic, by which I mean he's given up on his mic. Speaking of people who've given up on their mic, we also have Deirdre.
I blame Twitter on Android.
See, this is punishment. So we had Justin come in here and tell us about how Pixels are actually more secure than iPhones, and we all kind of just let him say it, and Deirdre got to feel good about herself. And now that we have to use our phones to do something, suddenly me and Thomas are here having an almost working time, and who knows what's going on in Android land.
It's obvious that Android is second for any new features for the Twitter dev team. They go iOS first, and then maybe it shows up on Android and it's half broken. And anyway, whatever.
All right. So this is an hour of time in which you are wasting listening to us. I think at this point, we will take audience questions, comments, and concerns. It's okay, even if it's not a question, more of a comment. There is some feature to request talking, to request to speak, and I think we can just rotate through people, and if no one says anything, we'll keep talking about Java. And so that should be motivation enough to request
or signatures, because someone nerd sniped me into signatures. So
before we talk about threshold signing and stuff like that, somebody should ask a question because this will get inscrutable real quick if we start talking about the signatures.
Yep. If your cryptography implementation is making a weird noise, please tell us about it.
We will just promote Matthew to speak if no one says anything.
Yep.
I think we should just do that.
All right. Well, he better be looking at his phone because I just invited him to speak.
We're bad at call-in shows.
Clearly.
Hey, it's our first one. We're doing it.
That's because our call-in show is actually implemented on top of a virtual machine inside of a compression algorithm, and so it just doesn't run very fast.
Where you're just like XORing clips in your fucking GIF, PDF, JPEG decompression thing.
I had to figure out, I've never allowed Twitter to access my microphone before. I'm sitting here desperately figuring out how iOS permission settings work. But I think I've finally got it.
You definitely got it. You're on with us right now. What's your question, caller?
All right. So I want to know what everyone thinks about, at least certain people in the world, favorite subject, which is client certs. I feel like they've gotten a really bad rap lately because, they're kind of hard to use, but they also give a lot of kind of nice properties where you're not just sending a token over the wire, and they're pretty widely supported in a lot of stacks. Should I use them? Should I not? I'm afraid.
Oh, Thomas.
We actually have a whole episode about this that's stuck in editing hell.
Oh God, you're right. I was like,
that hasn't been released yet. We recorded it 2 or 3 months ago at this point with Colin McCarthy, who probably just thinks we hate us now because we still haven't released episodes that have been recorded after that since then. But I'll let Thomas throw the first stone.
I have an answer for this already written Hacker News, and I'm trying to find it, and I can just read my Hacker News comment.
That's some engaging content right there. Let's all just read Hacker News comments.
All right, I'm gonna freestyle it, so I'm gonna be wrong about things, but I'm always wrong about things, right?
Are you implying that Hacker News comments are right about things?
Well, when I write them, they're as right as I normally am. I don't get more wrong when I write Hacker News comments. So we use client certs for things here. I have a general take that I think client certs make sense for defining kind of static network infrastructure. I buy the idea that that's workable. So for instance, we use Console, the distributed KV database for service discovery. We use a lot of Console at Fly.io, and to talk to Console here, you need a client cert. We have a mesh of client certificates that you use to get access to it. And for me, that's kind of like network topology. It's kind of just basically deciding who's allowed to use that link between servers and Console. But we don't do We don't do any there's no interesting authentication happening off of the encoded parameters in those client certs. So the client certs don't make any assertion other than like the bearer of the certificate is authorized to talk to console. It's like a static secret that's stored on the disk on the servers. Essentially, it's a bearer token. So I'm fine with it for that. Like I would try to these days I would try to use WireGuard for that instead of using TLS for it, just because WireGuard is so much less complicated. But like I would buy it.
That's a little orthogonal, right? Because WireGuard has, the Diffie Hellman keys in it, but you could be doing a client certificate protocol for key distribution
You
junction
could,
with
that-
WireGuard. Like,
Yeah.
in
But the way that client certificates get before Kubernetes hell, the way that client certificates got used was essentially defining virtual links. So like they were constrained to a single application or whatever. But that's kind of how I saw them. Like you can pick away at like that the analogy I'm drawing here, and it's not a great analogy, but like for like really high level who's allowed to talk to who type stuff, like what parts of the network, what servers are allowed to talk to which servers, I'm fine with them. There's like we wrote a long post a long time ago about all the different ways that you can authenticate connections between like components of like a microservices architecture, or like that we would call it like the intra-services or the inter-services authentication.
a child's garden of inter-service authentication schemes, June 12th, 2018, latacora.micro.blog.
If that blog is still available, right? So we made some noise about client certificates as being a sane way of expressing authentication between your own services in that post. And at the time, like I was pretty bullish on client certs for that stuff. And then Colin McCarthy wrote a long string of tweets about why he didn't like client certs for that kind of environment. He has some good reasons why he doesn't like them. I guess the first thing to know about that is that if you're I mean, Matthew, I'm sure you're obviously familiar with this, right? But if you're familiar with how like Amazon sees request authentication, sees doing authentication between services, they authenticate requests, right? All of their individual requests, request by request, are signed. And they like that for a bunch of kind of clear reasons, right? So like gaining control over the transport between different services doesn't give you like naturally the ability to spoof a request or something like that, because you still need to be able to sign the request. They're not really trusting the transport. But client certificates are intrinsically kind of transport based, right? So if you have control over the transport, if you can get the transport to issue new requests, and that's what you're relying on for authentication, then the client certs aren't helping you anymore. And there's like a really obvious example of this, which is SSRF. But in general, like SSRF-like attacks, which these are places where you're tricking a service that you're talking to into making an HTTP request for you. Well, those requests, if they're routed over that client cert authenticated channel, client certs aren't helping you there, right? You're able to make arbitrary requests over it. So I find that argument pretty compelling, right? Like individually signing requests is its own bucket of worms, and there's lots of things you can get wrong there too. But there's kind of like a fundamental kind of impedance mismatch between what you're trying to do there, between kind of protecting and authenticating a channel versus protecting and authenticating individual messages. And he would say, and I would agree, that it's protecting individual messages, that's what you want to protect in the first place. So that's where you should kind of put your energy. There's other like more tactical problems though. The biggest one is that to do client certificates, to actually implement them, you're naturally going to use a pre-existing TLS library. Like nobody writes their own TLS library. It would be insane to do that, right? And pretty much every TLS library that exists was built for the Web PKI certificate model, right? With all of the assumptions that are baked into doing Web PKI certificates. And so you have like, there are weird corner cases where like your libraries didn't expect to do the kinds of authentication that client-server authentication does. And you can wind up with, accidentally authorizing things that you weren't supposed to authorize. I'll let David, pick me apart a little bit more while I go read the comment where I wrote more about what actually happens here. But that's like the top two things where like the library support for it, like you're in a weird corner casey place for TLS. But also fundamentally what you're trying to do is, it's not a perfect fit for what you're trying to build up.
Thomas might be the first person in the history of the internet to be like, I need to make sure this is more accurate. Let me go read the comments of this article. But I completely agree that like client certs are great for authenticating transports and bad for authenticating requests, and really bad if you're using your transport to authenticate your requests. So the big question is, are you in a request response system or are you in a transport system? I think client certs are great in SSH. I think that more people should probably be using that instead of just authorized keys files.
Hmm.
And you can do some cool stuff in that space if you want to write a lot of code, like issue short-lived client certificates bound back to, say, an SSO and YubiKey login on your IDP. So you could like generate a key on your YubiKey and then web into something and SSO into your IDP, and then that could sign your key backed on your YubiKey for like an hour or 2 hour long cert,
I found it.
and then you can sign into that.
I found it. All right. So I was looking for Column's example, right? Because it's a good example, right? So I remember like a little while ago when we talked about it on this podcast, right? Where we were talking about different token formats.
Yes.
And I was thinking about, and we still are going to implement macaroons for FlyIO. And I was going around like, what library should we use for macaroons? And there's like a Go macaroon project and a Rust macaroon project and a macaroon standard. And every clueful person that I talked to hates those things. And I was surprised by how much vitriol they got, because it's like macaroon. One of the nice things about macaroons, it's a very simple, it's a very simple construction. It's hard to mess up, right? And the big complaint they had was the macaroons, kind of as expressed in macaroon libraries and then the standards, aren't typed. It's all just like a weird string DSL that you wind up. So it's like you wind up with like this ASCII heat equals value thing that you parse. And that's how you figure out, like, does this macaroon authorize me to do this other thing? Colin's example for client certificates is he was doing like X509 stuff for a client of his at some point. And like the CEO's admin assistant, like his secretary, had like, root access to absolutely everything because her email address had the string admin in it, admin assistant. And the reason that happened was because X509 is so fucking complicated that after you get the MTLS part of it working, if you're going to try and authorize based on things that are actually in the certificate, what you're really going to do is pull the name out of the certificate and try to parse it somehow. Like, it's the most natural thing to do there. So there was like some regex there was how they were determining that you had admin access.
No.
Because it's not like, that's not to say X509 is not typed, but it's plausibly deniably typed in that you could express anything you wanted to, but no one would ever do it, right? Like you would just embed things in the string and then parse the string. So this really good example is that like the ecosystem for X509 is so janky, you don't want to kind of implicate any more of X509 than you have to. But if ultimately your assertions that you're making about this request, you're going to express them in a string somewhere, and you have to parse the string, and then you're going to fuck up parsing the string, which I also thought was like maybe not that specific example, but you are probably going to write ad hoc parsers for things that you pull out of X509 certificates, and like that also would terrify me.
Yep.
I'm not against them, right? I'm fine with them, but I would kind of go out of my way not to use them if I had the option to. Matthew, I don't know. Is that a good answer to the question? Does that not make sense to you? You have opinions about this stuff. What's your opinion?
Yeah, I mean, I think there's so many foot guns. David mentioned something really interesting, which is you brought up SSH client certificates, which I think a lot of people don't use SSH certificates, but and one of the reasons that people give for not using them is that, they're this special thing, they're not X509, right? And like I think that a lot of the foot guns we talked about are like caused by X509 specifically, right? And kind of SSH has these relatively nice, relatively simple formats that I suspect is harder to fuck up. And I wonder if maybe we should just like use SSH keys for more things.
So there was a point a couple of years ago when I was still at Hannukah that I had to do a design for like a cryptographically authenticated enrollment thing for an application. And I was putting it together, and I had never done one from scratch before. And I started using SSH certificates as kind of my reference point for them. And by the end of it, it's like, we should just use it, SSH certificates. They're not X509. It's a really simple format. It seems like it's a hard format to mess up. And they're pretty expressive, right? Like I like SSH certificates a lot, right? And like I think the important thing to know if you're not like a cryptography nerd is that SSH certificates have nothing whatsoever to do with, TLS certificates. So those are great. Like we'll never be able to use them in MTLS, but they're great. We just switched over to all certificate SSH access at Fly, and it's been wonderful. It's been awesome.
With Ed 25519 keys. I presume.
Yes, with that two.
Nice.
But also, MFA access tying it to our, our SSO system and all that.
Oh, that's
We had
excellent.
ad hoc stuff. We had key signing stuff that we're using from like Bastion hosts and stuff like that, and pretty much
Yeah.
all of that's out the window now, and it's all just
Nice.
SSH good. Client certificates, I'm not so sure about, but like I don't know. I mean, you seem to think they're unfairly maligned. I think they're reasonably maligned. So I don't know.
Hope that helps, caller.
So I was notified by Adam Langley that apparently the request to speak button didn't even exist. It may or may not exist now. Also, I think Adam's given up on us and left.
Ooh, hold on. Let's
But
see
if
I
someone
can
can find the request to link button, the request to speak button, and hit it,
Anybody
that
here
would
wants
be
to
a positive confirmation that it does in
Anybody
fact
who-
exist.
Yeah,
I've
anybody here who wants to
invited.
pretend to be Adam Langley. We'll allow for pretend Adam Langley.
I have invited. I don't know if Adam can hear us, but I think you need to be on a mobile device. You cannot
Yeah, he has a
Speak.
pending invite.
you cannot speak on browser, which
Oh,
is
George
dumb.
requested.
Good.
I see. Get a quick view of speaker requests.
Approved. Cool.
Oh.
Yay. Hi, George.
Is that George?
Hi.
Hi, George. You're co-hosting with us now.
That's great. You made me install Twitter just for this.
Hey.
It could be worse. We could have made you install Clubhouse.
Hello, caller. What's your question? Who's that?
That was addressed to you, George. No, that
Oh.
was me accidentally hitting the wine glass I was drinking last night with the beer glass I'm drinking now.
Great.
Awesome.
Yeah, I actually do. Thomas, something you were just saying is highly relevant to my interests. Did you say that Fly actually uses like an SSH CA and like Mint certificates for internal service auth?
Wait, for service auth or
Whoa,
for
whoa, whoa,
SSH
whoa, whoa.
auth?
Yeah, no, for SSH auth. We don't do inter service authentication with SSH. We don't have SSH channels between. We use most of our serious inter service auth at Fly is done with IPv6 and BTF code. So our general strategy is we try to create a platform where we can trust source IP addresses by locking them down and controlling the entire network. So generally, if we're going to make them like, within the next month or two, it's going to be a combination of that like, these kind of special semantically encoded IPv6 addresses and macaroons is kind of where we're going. But we use SSH to like, do deployment infrastructure work all the time. And that stuff now is all, certificate based.
Okay, cool. I don't think I've ever encountered anyone like really leaning into that. So I assume you will write it up or something at some point.
You're talking about SSH certificates, or you're talking about services off with this?
SSH certificates.
I feel like we're kind of behind the curve on that. Like I think my impression was that all the cool kids were doing cert-based SSH for things. Like if you have a fleet of lots and lots of machines, which we're getting to the point where we're starting to have, like when I joined, it was kind of silly to describe us as having a fleet of machines. Now it's making more and more sense for us to like, talk about that. And I don't know how you would do it otherwise.
I
Do it
got an
badly.
intern to roll out SSH certs to like an entire fleet of machines and a company worth of users a couple of years ago, and like it was an intern project worth of work.
Yeah, George.
Hey,
Get better interns,
excellent.
George.
Yeah, the best possible answer to any question is like, oh yeah, everyone's already done that work before you.
Yeah, everyone's already done the work. You're actually bad at your job. Please leave now. No. No, I've actually never used SSH certs aside from whatever magic was being done at Google when I was there briefly, which I think involved like SSH over HTTP or something really very Google.
SSH over HTTP? Why? Because something boring corp or whatever?
I couldn't tell you, and I
Okay.
don't know enough of the details. I think looking for more callers.
Thank you for your question, caller. And if we don't get a question soon, I might have to flush my cache of ECDSA versus Schnorr signatures.
My mom says it's
Or
not.
we'll have to talk more about Log4j.
My mom says it's not urgent.
I think, speaking of Log4j, actually, I just love any situation in which people learn that you can't parse non-regular languages with regular expressions. That always just gives me Lots of joy. I feel like that was many people who like went and got CS degrees at some point had to take like theory of computation and probably didn't take that much away from the class, except for some languages are regular and some are not.
Yo, I did not have to take theory of computation for my MIT computer science degree to graduate. And I knew some physicists who took theory of computation for fun, but I was not required to take that course. So I might have been surprised if I paid more attention to Log4j.
David, I have a write-in question.
Oh,
Yeah.
okay.
This is from Jeremy. Are you guys ready?
Yes.
I'm ready.
Long-time listener, first-time caller. First question, why did nobody think about some protocol for keeping multiple U2F tokens in sync so I can keep one in a safe and don't have a single point of failure in my email account? I know Yubico has a draft spec out now, but this would have been better in U2F proper. This is going to be a question where we all just basically agree with him, but yeah, that's the question.
Yeah.
Is it? Like that's not clear to me. Like don't you just want to register a second token?
The current standard operating procedure is you have one that stays in the fire safe for, super extra backup, one that is super convenient for your mobile device, and one that is super convenient for your non-mobile device. And you basically have the new standard thing, right?
Yeah, wait, I was in method acting mode when I was reading that, and I took over his vantage point for a second, and in that moment I agreed with him, but now I'm wondering why he's asking, because I totally agree. Like, why would you want
Well, I think the big issue is then you have to like for every service you're using with it, you have to go and take it out of your safety deposit box or your please don't steal this box that you keep in the closet, and register your second token across 10 services, 15 services, whatever.
Yeah.
Like the other day, I counted in my password manager and I had 23 different Slack accounts. So you can understandably not want to set up like YubiKeys for all of those.
Yeah, and I want to admit that I have several UTF/WebAuthn devices. I have micros in my laptops. I've got the secure element in my phone and the secure element in the M1. And I have the touch ones on my fucking keychain. I have two of them, the old USB-B version and the USB-C version. And I have ones in my safety box. Guess which ones of those get updated the most frequently when I have a new service or I want to rotate keys? Basically, the one in the fire safe box gets updated for the fall back services. So almost every service worth its salt that has a recovery story says if you can't log in with all your multi-factor methods, we will try to fail over to a recovery email or a recovery phone number. Sometimes they make you register a phone number, and at least for Google they do this. And whatever your fallback is should be ultra super duper secured and probably should not have any fallbacks to it. And those are the ones that you really need to have that fallback multi-factor token in a fire safe box. But honestly, for all the ones that I use on a regular basis, I have so many devices that let me sign challenges and authenticate with my web service and bind to the domain. So I'll use those the more frequently.
Got oracles everywhere, just signing oracles all over the place.
Yeah. Yeah. But I think to respect the caller's question, I think the fact that UTF/WebAuthn lets you just do it with one, and if you lose that one, you're fucked, isn't great. The fact that we tell everyone to have more than one, because if they lose one and they only have one registered, they're fucked, is part of the problem. So I don't know.
I think another issue, so you can implement U2F or WebAuthn, I guess, with anything. You could do it with a Go program, for example. In fact, I have one of those that I've used in tests before, to make sure that WebAuthn was implemented correctly. I have my shitty insecure WebAuthn Go program that just writes out a key to my home directory and so on. First of all, so the reason that WebAuthn is useful or anything is twofold. It's that the browser is like acting at a privilege layer above everything else,
Yep.
and it's coordinating everything. It's ensuring that like, oh, I know that this key is associated with this site, and enforcing that the signatures are done via like the protocol, which includes like signing over the name of the website that you are in a challenge that you're authenticating to, so that when you try and U2F into the phishing site on attacker.com, your signature includes the word attacker.com. It doesn't do you any good, right? So it's non-forwardable. But then the other thing that people miss is that like it's next to their computer. Like that's actually something that's important. There's a reason you can't you can't use just like a phone as a WebAuthn token most of the time for your laptop. The reason being, like, you have no idea if you are authenticating a web session on your laptop or on Deirdre's laptop or on some attacker's laptop. If you want to think about it in terms of like a cryptography style game, imagine your phone is a WebAuthn token, and there are two people with two laptops signing into your account, and you can't see the screen. And the way that you win the game is by having a better than 50% chance of guessing who's signing into the account, laptop A or laptop B.
You do have the thing now, which I think the Google identity folks are trying to add the new WebAuthn 2 or whatever, where you can have your key rooted in the secure enclave on your phone, and it communicates with your browser on your desktop via Bluetooth to make sure that
partially via Bluetooth.
It's like making sure that you are physically close to the user agent via Bluetooth, but it's actually like routing information through Google servers. It's very like, I get it. It's also kind of convoluted.
Yeah, and it's not ideal because like anyone that could snoop that Bluetooth connection could also like fake it. But or you could be authenticating any laptop within range of your Bluetooth session, basically. And so all this to say that like physical proximity is kind of like an implied part of U2F or WebAuthn. And so having like a sync mechanism back to another key might go against that some, and also a sync mechanism to another key. If you were to ask, say, for example, former EFF lawyer Nate Cardozo what that is, he'd be like, oh, that's a backdoor. What you're describing is a backdoor. And so there's definitely questions involving that. I think I think, you know, at the end of the day, we're gonna end up at something like using phones for this, and then like having some sort of sync solution between your phone, and that's and you know, with TPMs and so on, that'll probably go not in a way that's not too shabby, or you can always, you know, transfer with like QR code or something. It's just, it's always tricky whenever you try to build a what is effectively a backdoor.
There's a
Look at the
George,
yeah. Well, so if you look at the UX that's developing around like, you know, blockchain hardware wallets, they try to embed, you know, some kind of like display on the trusted hardware side so that you can verify, you know, a transaction even if you've received it in some kind of like not directly plugged into your computer way. So if you can imagine the phone version of that isn't terrible, you know, where like your laptop can request something from your phone and like identify itself and what it's trying to do, and then you say, oh yes, that is the thing that I'm trying to log into on my computer right here right now. Maybe that, you know, maybe that could work, right? You can imagine phones being powerful enough to do that in an actually usable way.
Yeah, the tricky part is how do you identify the web browser, because in the web case, most of the time anything that you could pick could be faked by the attacker. Location, IP address, user agents, like all of those things you could route around with a proxy or just with a web browser that lies. So it gets a little more complicated.
But why did I install the web browser that lies?
Well, no, only the attacker needs to install a web browser that lies, right? Because the attacker installs a web browser that lies and says it's in your house. And then you get a request on your phone that says, do you want to authenticate this web browser that's in your house? And you're like, sure, it's in my house. But and actually it's, you know, across the country or something.
Google's able to get around this by having a compatible WebAuthn browser, having the backend of the web service you're trying to authenticate with connected to your phone, and it knows your identity, and it's able to be like, you have a registered device with accounts.google.com. Here is an alert on your phone. It's like, do you want to approve this login request and, you know, do whatever kind of pseudo signing challenge confirmation that they do. But,
It's pre-registration is the way that you get around
Yes.
this. If you can just say that you've pre-registered every browser that you've signed in from, then you've like trivially or pre-registered the browser to the phone. So like there's some web extension that Nick Steele wrote when he was at Duo with part of like the WebAuthn spec that showed basically a QR code and you had to scan it on your phone. And then once you had done that, you transmitted some sort of key material between the browser and the phone. And then with the help of a relay server, you could have the phone authenticate things in that browser.
I like that. Cool.
Yeah, that's cool.
Good
The
question.
tricky part is like if you're a company that's trying to like build some sort of off solution that's user facing, you can't really be like install this Chrome extension unless you're in the cryptocurrency space. But like if you have normal
Yeah,
users,
what's wrong with that?
We have a question in a chat somewhere from Jacob. Question is, where would your first, second, and third ideal real-world post-quantum crypto deployments be, as in what technologies, modalities?
I should definitely get my opinions in here because I have so many of them, but I know so much about this space.
My opinion is that quantum computers, similar to birds, don't exist. They're a government conspiracy.
I read a breakdown the other day of like the progression. It was a really good post. I think Steve Weiss posted it, or Steve Weiss retweeted it, and that's how I found it.
Yeah.
Steve Weiss dropped off here, and so I can't continue messing with him about it. But like it was like a graph of the progress that we need for both error correction and for the number of qubits we have. Because like the way you actually build, the way we think you're going to end up building a real quantum computer is that you're going to like collect a bunch of physical qubits into a logical qubit that you tie together with error correction. So like the actual raw number of qubits is much less important than kind of the I don't know, the product of both how many physical qubits you have and how good your error correction is, right? And there's like a graph of like where we start to get interesting problems that we can solve, and we're nowhere close to like the border of that graph where we could do like basic chemistry things. We might be able to do better with quantum computing. Like, you know, it could be forever and ever and ever before we get there. And my takeaway from that was I never have to worry about quantum computing.
I think we are doing the right thing in that we are doing the research now to have quantum resistant cryptography for just in case, and for those, users like long-term storage or, whatever, like the government or the military or whatever, who like, no, really, they need to encrypt something or they need to be able to do key establishment and it needs to work 25 plus years from now. Like that's part of their requirements. We saw that, elliptic curve crypto was quote unquote invented in like 1985, and it took at least 20, maybe 25 years for it to get deployed at a efficient and widespread scale. I think we're doing a lot better now, but we've definitely got a lot of options, but they're not perfect yet. And there was actually a nice post from a presentation from Stephen Galbraith about how like new cryptography gets introduced every about 10 years. And then when it's first introduced, the math is slow and people are like, well, this is not useful because it's too slow or inefficient. And then like not that long after, someone will make it much more faster with like algorithmic improvements and math. And then all of a sudden it's much more useful and you find much more applications for it because it's finally efficient enough. And we've seen that happen over and over again. I do think it's going to happen with all of these quantum resistance proposals, especially the isogeny stuff, which keeps getting faster and stays secure, unlike some other stuff. But I'll go back to the original question before I forget. Where would your first, second, and third ideal real-world deployments be? I mean, number one is getting TLS quantum safe. We just do a hybrid with either psych, supersingular isogeny key exchange, or there's some proposals to make SIDH actually usable in a static setting again by doing a little check of the parameters to make sure that they're safe. So we might get that back and actually get something that's Diffie-Hellman and not a key encapsulation mechanism. Or you can do your favorite lattice. The Chrome people have done deployments with those, and they had some performance or latency issues, but like they will work. Like if someone is very worried, soon, that it's not that they're in an insecure place, we have nice options that we can slot in, and we've tried them, and things don't break terribly, and we can do that. So TLS on the web, on the internet, is probably number one for key exchange. We're not that worried about signatures for kind of trust on connection for that. It's mostly like long-term key establishment for recording the entire traffic. That's probably my number one. And then probably I'm biased because I'm in a kind of blockchain-y space, but like trying to find post-quantum like key stuff for all of your blockchain crap, like everything in the fucking, I don't want to say Web3. I disagree with the term Web3. Crypto 3, all of the fucking crypto stuff is
Crypto 2, Electric Boogaloo.
exactly, like all of that shit is not quantum resilient except for like a handful of exceptions. So like if that's going to keep going and there's tons of fucking money being thrown at it, somebody come up with quantum resilient versions of all the things you're building. Get rid of those ECDSA signatures, get rid of all of your key establishment that relies on quantum insecure mathematical problems. Hopefully that helps, caller or questioner.
I figured that they were asking what your preferred crypto systems were.
I thought that, but then they asked what real world deployments. And so I reread it as like, where do you put the post quantum crypto, I guess.
I'll answer what Deirdre's favorite primitives are, and the answer is isogenes.
It's
Correct.
like, you're like isogenes, then lattices, then McLeese, right?
So the thing is, you can't do fully homomorphic encryption with isogenes. Well, you could, but it would be as inefficient as all the RSA implementations of the thing, and you probably wouldn't get the fully. You would just get the homomorphic encryption. You can do crazy shit with lattices that you can't do with basically any other like mathematical primitive for cryptography. So I have to give props to the lattice stuff, you know, where they can do things that isogenes can't. I love the structure and the algebraic niceness of isogenes stuff. I just think it's neat, but there's some stuff that it's not really applicable to yet. And then McLeese is boring. I think I would.
What is McLeese based on? Like, it's not an isogeny and it's not a lattice?
It's linear nodes.
Oh, okay.
Oh, it's old school. I think people like it because they understand it, and it's just been sitting there for like 40 years. And people have been like, you know, hip checking it occasionally, and it's still standing. I think it's mostly just people understand it, not that it's super crypto analyzed to death. There are some constructions that are based on block ciphers and hashes almost exclusively, like no codes, no multivariate polynomials, no isogenies, no lattices. It's like really bare bones kind of symmetric crypto stuff. And you're able to build things like Picnic and signature systems and proofs of knowledge and other stuff like that from like really like stuff that we really get, and we really have a good sense of why they are post-quantum secure. I do like those, and I hope that more of those continue to live around. I don't think Picnic survived into the last round of the NIST post-quantum competition, but I do like those, and I want to see more of those, especially like zero knowledge proofs and stuff.
Matthew, I believe you had another question.
Yeah, I do. So I'm buying a modern car, one with electronics in it. And, you know, one thing that I'm worried about is that it seems like cars are being stolen by key fob cloning or relay attacks on them. Is this actually a hard problem, or do car manufacturers just not care, or do they just not have like good cryptographers working on it? How do we fix this? How do I, you know, have confidence that someone's not going to come up with a little black box they got from somewhere and drive off with my car?
So I have part of an answer for you, and the first one is just never park your car anywhere. I believe you used to live in San Francisco, so that should be very familiar to you. Thing two, I don't have a good answer for you, but since a friend of mine, Ethan Stark, is in fact in the audience, I'm going to share an anecdote, which is that no, the car companies do not have good people working for them. Because, for example, my friend Ethan, very smart person, he works for Waymo. We had another friend in college who was not as smart, whose name I will not say, who was not that good, and now he works for Ford. And I think that's just kind of the way the world goes. That you're expecting that certainly not necessarily true for everybody, but I think the top tier cryptographic talent is not getting hired by Ford. Also, can I recommend buying insurance?
George, what do you think about key fob cloning? You have the real answer here.
I mean, cloning seems like a difficult problem to solve. The relay thing also seems like a difficult problem to solve for different reasons. I think that's probably also partly why they haven't fixed it, right? Because like for most cars, you kind of need like any random dealership to be able to clone to like make a new copy of the key. And I know that like for instance, Tesla keys, uh, like may not have that property. Like it is under some circumstances very irritating to get a new key made for your Tesla, presumably because they have like actual security that has to go back to the mothership to be like rekeyed or something.
There's almost every year at Real World Crypto, yet another demonstration of either cloning or breaking or, recording the entire key exchange between your fob and your Tesla, and then just like doing the breaking and replaying the correct like manufactured fob that like doing the registered because they found the like box that you deploy to your Tesla service installation, and then they like, oh look, we shall just use this to record the handshake between a fob and a car, and then use that to rekey a new key fob and use that to break into the Tesla. There seems to be like another iteration of this sort of thing every year, and I don't think it comes down to the cryptography so much as the like kind of what George said is like you need to be able to service the car, and like that kind of builds in these fundamental vulnerabilities into like these protocols. Yeah.
I did like a utility RF thing once, like just speaking to like the constraints that you're working with. So I guess to start with, right? Like I'm a little confused by key fob cloning to begin with because cars are easy to steal, and like the most marketable
Yes.
cars to steal, like the lucrative cars to steal, don't tend to be key fobbed anyways. Like they tend to be just like kind of garden variety, like whatever Honda Civic or whatever, right? I don't know what the cars are, but like the cars that tend to be the most lucrative always surprise me, and they're not like super modern advanced cars, right?
As XKCD reminds us, the $5 wrench is going to do a lot better than any crypto attack on your car.
Yeah.
Which, like living in Chicago, right? The way your car is going to get stolen is that somebody's going to like, as you pull up to your parking spot, come up to you with a gun, right? So,
Mhm.
Chicago is great, but like carjacking is real.
Mhm.
So, so I guess like, but you think that like the actual cryptography part of that problem is like a really solved problem, in that we know how to do like network authentication over untrusted channels. But like I've been on projects where people did really dumb, bad crypto things because of the constraints, both of their SOCs and the crazy RF constraints that they have, that they had to use really, really small messages and stuff. And like we wound up with like 16-bit CTR counters and things like that. Like that's something that happens. So you can kind of, if you're not like spending all, but also like my other thought there is like I don't know anything at all about the caliber of person that works at Ford. I'm sure your friend is awesome. You refer to him as your friend, so I'm sure you're being sarcastic about how bad he is. But like there's a huge cottage industry of security consultancies working for every major. It's a huge source, or it was at least a couple of years ago, like a huge source of revenue for the big software assurance firms, just doing design and review work for car companies. So like even if they don't have like cryptographers on staff, right? Like they have an army of cryptography consultants that want to come in and find every possible thing to tell them to do better. Those contracts are worth, $100,000, $200,000 a pop, right? So like the consultants definitely want to do that work. So I'm like, I'd be surprised to hear that they don't know how to do it, right? Yeah, I mean that's all I have on that.
This actually feels like a fine use case for client certs.
I have another written question again from Jeremy, and it's a question I like more than his previous question because I have opinions about it. You guys ready?
Yes.
Okay, hold on. I got to get into the mode, right? So Jeremy asks, first of all, he says, thanks for getting to my first question. And Jeremy, you're very welcome. Why do you think that there has been no real effort to create a cross-platform zip alternative with real encryption? And what do you think it would take to create one? You got to raise questions better. I'm going to read them like this. I have to be able to read them with field support. It doesn't seem to be too hard to combine age and zip somehow. I could not agree more. I have friends that work. We all have friends that work at big tech companies, and every once in a while they'll reach out, like they'll do like an annual product roadmap-y thing where they're trying to figure out like what cool crypto things should they do. And then for some reason they ask me. I'm not a cryptographer, but they still ask me what they should work on. I assume they collect it with lots of other people's feedback, and I fall on the bottom because every goddamn year my answer to that question is I should be able to right-click on a file in my Finder or my whatever the Windows calls it or whatever, and encrypt a damn file. Which you can't do. So there's no good reason why. Like I would assume the only reason why we don't have this is because Google and Microsoft and Apple would have to agree on something. But like that's really easy, right?
We have one of the creators of Age on this call, and I've just asked if they wanted to speak. But I feel like we are getting really close to that, and it does not involve one of the big, operating system developers to be part of it.
This is already possible. You simply modify the defaults text file in the correct Etsy directory so that you can get GPG when you right-click on something in Nautilus.
GPG, we kind of talked about before, like, you don't go to the standards body, define a standard, and then have everyone go implement it. Someone goes and designs it and implements it, and then it becomes a standard. I think we might want to see Age kind of be part of that. Like, Age good. Age thought it through. Now, Apple, Microsoft, Google, etc., go and like make right-click encrypt with Age, decrypt with Age, like part of your operating system or something like that.
I mean, you could probably make a bigger dent just by having some major operating system vendor. It doesn't matter which one of them. Just have this as a first-class feature of the platform, and then publish what the format they used for it was. Like I love Age. Is that how we pronounce it?
Yeah.
I love all this work that's being done, but like it's still a cool kid thing, right? Like if I saw .age files in your home directory, I would assume you're a crypto nerd and nothing you have is worth me hacking. So.
It was very designed to replace the like encrypt file like use case of GPG.
It's a thing I yell about a lot online. I should yell about it every year, like on January 1st. Just that, like, obviously, it's easy to encrypt something well if you download a program that does it. Like, and then that problem is just like, how do you find the really good ones? And the answer to that is really simple. You just find Age and run that, right? But for this actually to be workable, like I go back to when I was doing consulting work, right? And what I have to be able to do is I have to be able to do this with clients without telling them to go install something. The moment I tell them they have to go install something, I'm done. It's just not going to happen, right? Instead of encrypting something after downloading it, what they're going to do is reply to me with an encrypted zip file. And encrypted zips are the worst thing on the planet, right? There's nothing worse than encrypted zips. So
an unencrypted zip?
No, I think
they're worse, definitely.
It's like what's worse, a file that's claims to be encrypted with AES 256, but is instead encrypted with Basomatic, or a file that straightforwardly says it's not encrypted.
I sent a professor a thank you note after I graduated with my PhD, and they responded with a GPG encrypted message, and I still have no idea what they said.
To this day, you haven't read it? So that's a good question. Unfortunately, it has a really simple answer, which is that we're never going to have a good encrypted format, because it would require collaboration between rivals who don't trust each other. I was going to say Linux should fix this somehow, but I have to think like, well, then the Ubuntu maintainers have to do something, and that's even worse than getting Microsoft to doing something. So
we can get Jason to get it in the kernel somehow.
Yeah,
that's true. We haven't thought about this. Jason has the weird secret power where he can get Linux people to do things. So the answer is it has to be built into the Linux kernel. We have requests, and I'm letting somebody speak. Hello, George. Now speak.
Yeah, I was about to make that same.
We got George too. We let two people speak at the same time. Oh God, which chopsticks do we use?
My question is not security, not cryptography. Pretty clearly, whatever. So if that's not good, then I'll let George speak.
For it.
What why is Web3 a bad name? I just wanted to.
Ooh,
I just wanted to stir the pot.
No, you're saying that when Deirdre took a pot shot at Web3, I was going to stop her and hold her to account for working in cryptocurrency and somehow dissing on Web3. So I'm glad you asked that because you reminded me that I have
Cool.
to
Yeah.
with Deirdre about this.
Yes. So Web3 is obviously being like, remember Web 2? Well, now it's Web3, except it's not. It's crypto shit. It doesn't have anything to do with the World Wide Web. And now it's just like, oh, it's just a bunch of like DeFi and blockchains and smart contracts and stuff in a like distributed way, but it's not Web3, it's Crypto 3. But they're just going off of the hype cycle that Web 2 was.
No. Let's not let George keep quietly Jeffersoning on mute in the corner because he also works on cryptocurrency.
No, I mean I feel similarly, right? Like I you know, when challenged, I say crypto means zero knowledge proofs. You know, like I have not, like you say Web3 to me, and I have no coherent idea of what that means. The closest thing that I can think of is that if you have a bunch of people with, you know, like their Ethereum wallets or whatever plugged into their browsers all the time, you have accidentally solved SSO. Like, is that Web3?
All I know is anytime I see anyone talking about Web3, it has nothing to do with the World Wide Web, a browser, HTTP, any of that. It's about cryptocurrency, crypto stuff, crypto.
It's about this beautiful vision of a world wherein all human interactions are literally transactional.
No, that's called San Francisco, George.
Yeah, you know, no coincidence.
Yeah. And it's
Web3?
not competitive.
Oh, the DNS replacement? I don't know if that counts as Web3 or not. Probably.
Yeah, see, I couldn't possibly say because Web3 is a bad phrase.
Did you get to bed pictures of monkeys?
I would.
DNS?
Bored monkeys.
Only if you could get a loan for a DNS name, maybe.
I mean, you can probably do that.
What is the line that you two draw between like this kind of self-evidently monstrous space of weird transactional Ponzi schemes, a top Ponzi schemes, a top Ponzi schemes that is kind of NFT or DAO stuff? Like, let's buy a copy of the United States Constitution. And like the scam there is that it costs more money to get your refund back than the refund is worth, so they just keep all the money. Like, what's the distinction you draw between that?
No, they still sent the money back, so they basically accomplished lighting $14 million on fire, or $30 million on fire. It's like a Kickstarter where when you get your money back, instead someone slaps you and then lights it on fire.
I get sort of in the same way that post-quantum cryptography is it's a full employment program for novel public key crypto system researchers. Like, I get the sense in which things like Zcash are a full employment program for people that want to do public key signature work. So I get like the technical attraction to it, but what's the distinction that you draw between that kind of work, you know, kind of cryptocurrency, zero knowledge proof, you know, anonymous transaction stuff, and kind of the tokenized pump and dump scheme stuff?
Well, one of them has users.
And that's not your one, right? Your one.
No.
Yeah,
There's like pictures of like lots of people at the Bored Ape party. Like, it seems like there's lots of people doing that. Jimmy Fallon has a Bored Ape.
Oh my God. I think
if you're looking for an explanation of the Bored Apes, I don't have one for you.
Yeah, neither do I.
I think a lot of the Web3 people, or at least the people I know that are into that, are building stuff on layers on top of cryptography that has been given to us by Deirdre and George and others.
A lot of it is on like an Ethereum platform with, you know, the sort of one global distributed decentralized computer smart contracts and stuff.
As we all know, Al Gore invented Ethereum.
Yeah.
Is the distinction then that Ethereum is bad? What things that function like Ethereum are like, that's the problem?
I think part of the problem is like fundamentally computing has been, someone writes a program and like you trust the person that writes the program on your computer or a computer. And now smart contracts are trying to be like, it is a global consensus computer, and everyone, it's like a fundamentally different computing trust model of like someone writing a program, aka a smart contract that runs on the Ethereum thing. And now we have to figure out who the fuck we trust and if the thing is secure in a different way than we've been doing it. But also, like, it's a lot of just kind of scammy shit because it's like complex and people don't understand it.
All right, but you're even that is like an extremely I build this stuff professionally take, right? Like the people who are mostly using this stuff, I don't think are sitting there like wondering about how robust their replicated state machine is, right?
Yeah.
So there's the distinction is maybe between like people who are kind of interested in like the mechanisms and people who like want to like get 20% yield on there. They don't really care what it is.
Yeah. And I will say that people were not the original Web 2, but just before Web 2, we had the original .com bust, and there was a lot of like people raising mountains of money for weird fucking web sites and web services that were just like either, vaporware or just a lot of money that went in a hole and nothing came of it. And I think this whole crypto, DeFi, smart contracts, NFTs, all this sort of shit is so like, there's tons of money being thrown at it. People don't understand it. There's still a bunch of like weird grift and vaporware shit happening, not dissimilar to sort of the, .com bubble. There's just a lot more cryptography involved in it. I don't know.
I think the people that really believe in it, that are doing Web3 stuff and not just like running scams all the time, or solely, looking for like 20% plus returns, are like view it as a way in which like Web 2, like Facebook basically was about like you create a bunch of content and then Facebook makes a bunch of money off of it. And the like community aspects around Web 3 are the idea that like you create a bunch of content and the users make a bunch of money off of it, is like what it's supposed to do. It's just, I don't think that will happen. And I think that any of the cases in which we've like tried to leverage the distributed consensus models that like have been created for cryptocurrency and Web3 and then tried to extend them to the real world, I think have been objectively worse in every situation than one in which you just used a normal real world construction. And that will probably continue to be the case until somehow we reach the point, if ever, in which you can in which it is more valuable to keep your cryptocurrency as cryptocurrency in terms of utility. Like I need to spend money and buy things and do stuff with it. Like until you get to the point where like regular businesses, if they took cryptocurrency, could leave it in cryptocurrency and still like do stuff with money. Like that's just always going to be the case, because as soon as there's the on ramps or the off ramps in the cryptocurrency world, you have a centralized structure, and then that's a point of failure. And whatever you do to address that point is just pretty much always worse than if you had just, for example, in the Sotheby's case, like there was no connection of the LLC that was actually bidding on the Constitution to the DAO. Like they signed a letter of intent that said they were going to do it, and they had the private key, but they could have also just taken all the money because there was no binding to the thing in the real world, to the thing in the crypto world. And so, I can appreciate the people that are like, let's try and get more access to financial systems to people, and let's get more money in the hands of users instead of Facebook. I remain skeptical that will actually happen, but I that's kind of the Web3 view. I think is, instead of money, you make content, money goes to Facebook. It's you make content, money goes to users, and then we're all magically rich and living in space.
I think the most charitable interpretation of, if you're going to put forth like the strongest version of the argument for why all of these things should exist, is that their experimentation in the field of like what if it were dramatically easier to like transmit money in a peer-to-peer way, right? Like we have kind of the best way that we have for paying people on the internet right now is like Stripe, but there are still fundamentally a lot of things that you can't do with the model that they provide, and they're kind of coming at it from the other way, right? Like trying to make it so that you can like programmatically do more and more things on like kind of fundamentally the same rails. And then there's a bunch of like strange people trying to reinvent it from like a totally different set of principles, and maybe it'll work and maybe it won't, but I think that's the kindest view. And then like because they are building financial infrastructure but like don't have a fraud department in the way that Stripe does, all of the fraud is also happening.
I just, just wrapping this up, I just say like I'd be one of the no coiner people. I'm a no coiner, I guess. But I'd be much louder about it. I'd like retweet a lot more critiques of cryptocurrency in general and this Web3 stuff in particular. Except that I always feel like if I did it, I would make Deirdre and George unhappy. I also figure like there's got to be something to it, given that you guys are both very smart and you work in the field. But I have a hard time getting my head around it, right? Because my immediate reaction, which I've never gotten over, is that like it's like tulip mania, right? Like it can't possibly be real. But I'm saying I must be wrong about that somehow. But it's still kind of my surface level belief about this stuff.
I would say when it was just a bunch of forks of Bitcoin, and it was just a whole bunch of different coins, and they were only marginally different. They were just trying to be the new Bitcoin. I would basically agree with you. But like it's evolving extremely quickly and with a lot of extremely interesting cryptography trying to achieve way different ends. Like there's the smart contract stuff, there's sort of provability stuff, there's a ton of weird stuff going on that's extremely interesting for a whole bunch of reasons. And so now I can't even predict where it would go. Where once upon a time it was just fucking Bitcoin and Dogecoin, and now like Dogecoin has a resurgence because like fucking Elon Musk turned it into a meme and then it crashed the next day. Yeah.
That part of this I have no trouble understanding that, right? Like the why it appeals to you, like as an engineering problem, really obvious, right? Like of course. So like I get like if you want to spend all your day working in polynomial cryptography or polynomial public key cryptography and isogenies. I guess there's no isogenies in what you do, but you know what I'm saying? Like really, really weird curved signature stuff and all that. I get that. I get the appeal there. Like if you want to do like hardcore cryptography engineering work, like it's a really good way to get paid to do it, right? It's just the broader kind of like what is it for that I have trouble with.
Sure, I get that. All right, we have another question that I want to get to before we run out of time. Okay, from Andrew. Can each host please come up with a distinct use for a Merkle tree that isn't a blockchain or certificate transparency? And I'm going to
go first.
No, I called it. I get.
My answer is no.
I have two. One, Sphinx signatures are hash-based signatures that require keeping track of keys that you've used statefully with Merkle trees. So that's one, and that's post-quantum secure, but it's a pain in the ass to use because of the stateful Merkle trees. And two, in the messaging layer security.
Damn it, that's what I was gonna say.
Yeah. They do all of the key management with TreeChem, and it's just fucking Merkle. It's sort of like transparency trees, but for your keys and your groups and shit, and rotating them and adding them and removing them and all that.
I mean, I don't know how much time we have left, right? But like, if this was just us recording normally, I would stop you and ask you to like define your terms there.
Okay.
Just on the assumption that not everyone listening to this knows what the hell Andrew's talking about.
Sure. So Merkle trees have been around for a very long time, and after Ralph Merkle, but they've become extremely in the zeitgeist because of blockchain and because of Bitcoin. You have a whole bunch of Merkle trees in Bitcoin. Like you need to hash up all of the transactions in a block, and you do it with the Merkle tree so that you end up with hashes of hashes of hashes until you just get one hash. And then you commit to that hash as part of your block, and you put that in your block header and all this stuff. And in Zcash, we have a buttload of Merkle trees for a whole bunch of different reasons, including no commitments and other stuff. So instead of just blockchain, you can use them for a hash-based signature like Sphinx, where you have to keep track of what things you've already used and what things haven't been used, and you can commit to the entire history of the statefulness of your keys by updating your Merkle tree, so it all hashes up to a single hash, your root, and then you can like keep track of just your root, because that is a commitment to the entire state of your Merkle tree of hashes. And then similar for messaging layer security, the way that they keep track of all of the keys of members of a group end-to-end encrypted messaging channel or session or whatever is they have a publicly available Merkle tree that everyone that can check when you add a new person or remove a person or rotate all the keys in the group. Everyone can hash up all of the trees at the point in time, all the keys and the point in time that everyone's supposed to be agreed on the state of all the members of the group into a root hash. And then you can all compare and make sure that you're all looking at the same state of all the group keys. And if you disagree, you can take some action like reset everything or kick or something like that, or, you know, throw an error. That's what those things are. Does that help? Messaging layer security is cool, and they're solving hard problems and distributed end-to-end encrypted group.
And one day, maybe something
Chat.
besides Wire will use it.
Yeah.
knows?
Well, WebEx
Does use it. That, I guess that
Yeah.
is kind of important.
Yeah. There are implementations that use it, but it's pretty cool because they're doing the hard work of solving all these weird edge cases and performance issues, and they're doing it. And it will eventually be an IATF spec. Cool. Thank you for the question, caller. We have another in the chat.
I think the real question is, why is anyone listening to us instead of watching the Tail Greeter Kier Bowl between Northern Illinois and the Coastal Carolina Chanticleers, which is a type of chicken?
Oh, there's a good answer on the Slack too, which is like Lake 3 style tree hashing.
Yeah. Sarah, do you want to ask your question?
Yes, I can go ahead and ask my question. This is going back to the previous topic about financial structures. I'm kind of curious what you think are going to be the legacy after effects of things like cryptocurrency. We have things like file transfers for ACH, so I'm curious what you predict will be legacy in 20 to 50 years. Also, if any of you want to feel old, think about how email was basically invented 50 years ago.
I mean, I think Bitcoin will not evolve fast enough, and that will be super legacy in not that long, especially as a lot of like things. Ethereum's trying to move away from proof of work to proof of stake like within the next year. And I hope that they succeed, because if they succeed, then a lot of other, you know, blockchains or, you know, whatever distributed consensus blahs will have, you know, a model to follow. And it's better to stop burning up all of our shit by just fucking rolling dice and hashing it and just praying to God that you get the right fucking leading 10 zeros. It's so fucking dumb. I hate it. That will not move fast enough, and I think it will look real dumb and janky and old pretty soon. But other than that, I don't know.
Oh, I mean, here's another way to think about this question is, what is everyone going to groan about in 20 to 50 years? Because we're like, fuck, why did we come up with this idea 20 to 50 years ago? Such that we have to deal with it now and have to maintain it and learn all of this arcane stuff. May or may not be inspired by thinking about GPG.
Spiffy, Kubernetes Spiffy, sidecar model, proxy, like building like weird layers of abstract network transports between services and all that. The idea that you're going to build your services to this weird service mesh that does MTLS-based security between proxies and stuff isn't like that's Corba, right? Like it's clearly we groaned for a little while about Corba and then it went away. And so that'd be my answer.
Oh, so sorry, you're talking about general technology, not just, you know, crypto financial crap?
I mean, it was themed on crypto and was inspired by thinking about financial structures and financial institutions. And so it's like, you know, we're adding craft upon craft. It could be security craft. What is going to be security in cryptography or security in cryptocurrency, however you want to define crypto, craft in 20 to 50 years.
I do think that there will be some development in terms of either thresholds, keys, or like multi-party computation that will make a single person with a single hardware wallet or device that is like the single point of failure for accessing millions of dollars will look like jank as hell. But we're not there yet, and I have a feeling that the thing that will happen will sort of be like, of course it's the way we should do it, why did we think otherwise? But we're not in that world yet. But like the fact that like hardware wallets are like, everyone's like super fucking into hardware wallets, or like storing a single point of failure key on your phone, and like that's as good as we can do right now given what we have. But I think in like a couple of years, after we've kind of gone through a paradigm shift of like what we can do, we will look back and be like, what do you mean there is like a fob in a vault and that is the only way to like access all of our shit? And you're like, are you kidding me? Like, yeah, that's the only way we were able to do this, like in ye old 2020 or whatever. At least I sincerely hope so, that we are moving away from that. And like that's not even just cryptocurrency, but like kind of the UTF WebAuthn keys that we have now. I sincerely hope that we connect, kind of do something better with multi-party computation or thresholds, key agreement or key establishment or signatures or something like that, that will make those single points of failure like a thing of the past.
I think Jack had his hand raised.
Ooh, Strauss.
Yes, hi. Somehow I snuck in, I'm not quite sure how, but yeah, for that question, I would go designing a world computer around a 256-bit word architecture.
Yeah, that's gonna get old quick.
Yeah, it already is, as I gather from certain issues I have seen opened on various bug trackers. Like it really lends itself to efficient computations on non-world computer architectures, and then people attempting to take things that are almost 256 bits and treat them as the same thing.
The subject work.
It's close enough that you think it works.
You guys are jumping on Ethereum, right?
Well, yes.
Okay.
Yeah. Ethereum, like for those who are unaware, computers like to deal with things in words. Most computers nowadays use 64-bit word architecture. So yeah, if you're doing your math or whatever, you process like a 128-bit number as two 64-bit limbs. Ethereum was designed around a 256 limb architecture. And I have in fact seen someone on the LLVM mailing list requesting adding U256 support to LLVM, so that they could then just compile regular programs into like Solidity smart contracts.
I mean,
you support the 7-bit architecture from 1983. Why not ours?
Yeah, like I would also try to do that if that was my target.
I think we'll all be regretting the Linux kernel in 50 years. Because I think having a kernel that no one has to maintain is probably a bad idea, or that no one is paid or financially incentivized to maintain.
Yeah, but this design has survived this long. I believe that we could still be dealing with this 50 years from now and kind of accepting it as normal.
Is this not true of all open source?
Yeah, and when has a open source logging library hurt anybody this week?
Throw me on the doll where the log4j hurt you.
So I actually had a question if we have time for another question. So cars, sort of rolling it back in a bit, cars have ODB ports into which you can plug interesting devices and like get a bunch of diagnostics out of your car. And in a completely related field, I saw that Tokyo put out their 0.1 of Tokyo console, where you could plug an interesting tool into your running async program and figure out like what stuff can go on with that. My question is, to the hosts, do you have any specific favorite tools for plugging into your cryptography or securities implementations and figuring interesting pieces out about their internals that the audience might not know about?
I was going to say Go Test. Like if I'm trying to, I had to do this with WireGuard like a couple weeks ago. We do this weird, crazy to SSH into an instance on Fly.io. We run user mode WireGuard and a full user mode TCP/IP stack, which is awesome and it works most of the time. But when it doesn't work, it's a nightmare. So I've been doing lots of WireGuard debugging, and we're trying to build tooling for people who like diagnose weird WireGuard problems they're having. Yeah, I wound up doing some work on trying to do like a reliable proof for like, are you able to speak WireGuard in the first place?
Yeah.
And like I was goofing around with the protocol there because I wanted to keep, I didn't want to have to run a full WireGuard like session for it. Like I just wanted to do like minimal number of packets for it. My general take on trying to do any of this kind of work when I want to actually tinker with a protocol, especially a cryptography protocol, is like I just find the Go implementation. I know that's painful for you to hear, Jack, but I try to find the Go implementation of something and then like vendor it into a project and hack it up and just write tests for it, which let me grovel through like the global variables and put prints all over the place and stuff. And it's, so WireGuard Go made that super, super easy for me. So that's kind of my same thing happens with TLS and with other weird custom protocols and stuff. I'll tend to start with a full implementation and Go and then hack it up. That's not the answer you want, right? You want like something like Tokyo Console, which Tokyo Console is also really awesome, and I'm really optimistic about it. We do a lot of Tokyo here, and it's very simple for debug. So I'm excited about it. I don't have any cool tools like that for the general cryptography side of things.
Yeah, like I guess the things I was imagining that people might say are stuff like, well, the SAT solver kind of stuff that people plug their protocols into, or GDB equivalents, but for that. But yeah, print statements are tried and true.
I also have to give a shout out to either prop test, like as implemented in the Rust crate, or another just like give me random data within certain parameters that I can shove into a thing like a deserializer or a parser or something like that, and just run it a whole bunch and see if something panics or breaks or throws an error or does something weird. You never know. Like even my own code, like we found issues because of prop testing, and that's kind of, it's just nice to be able to just see what happens with if you just shove some random data into a thing that you don't understand very well. I like it.
We had Jason on like a few weeks ago, and like at the end of that whole interview thingy, we talked a little bit about Tamarin and like what the actual getting started for Tamarin was. And at the end of that conversation, I really wanted to have a problem where like Tamarin would be helpful because he made it sound super, super easy to to do. So like people that are better with formal methods than I am have much better answers on this. David, Deirdre, you guys have probably better answers than I do too. But Tamarin seemed super awesome.
I've gotten very far in life with Go implementations and WireGuard. Like, I mean, sorry, not WireGuard. Wireshark. Looking at the bytes on the network is often very useful. At some point, it's not going to, like, once you get to the part that's just a bunch of AES encryption, probably not going to do you a lot of good, unless you happen to see plain text instead of, trick number one, look for plain text. But debugging handshakes or any network protocol like that, like just looking at what's on the wire, especially if there's a Wireshark decoder for it, or even if there's not, like there's a period in time where I could read TLS transcripts of handshakes just in hex. I've lost that ability, but
yeah, I think I wanted that didn't seem to exist when I was doing the WireGuard stuff was test vectors. For each step of the handshake. So test vectors are a good one too, right? Like, just like at this point in the handshake or at this point in like the construction that's building the running hash or whatever, for this set of inputs, the hash should be this. I ended up generating a bunch of them. I was going to put them like in a gist or something like that, right? Because I figured at some point somebody would want WireGuard test vectors if they're trying to build their own WireGuard implementation. So generating test vectors would be great too. Another good answer, I think.
yeah, those are good. I do that a lot. I have some Go code that's not yet released, but it re-implements some of the like SHA-3-ish and duplex constructions from the stuff on kekak.team, except in Go.
Yeah.
And so to test a bunch of that, like testing Cravat, testing Cyclist, I just took their C code and just wrote a C program that like output different transcripts and then wrote the Go harness to be able to read those transcripts and then run the same thing in my Go code and just diff the raw bytes.
Right. It's also porting kernel code to userland or porting weird operating systems to userland, right? I think another thing like this, I a tip I got once from Nate Lawson, right, which was super, super useful to me on a couple of different projects where it was like weird embedded operating systems or exotic operating systems or things like that, or like enclave computing and things like that. If you have a project where you're trying to find vulnerabilities and that kind of stuff, actually testing the real system is a nightmare because there's no tooling. But it's surprisingly easy to take any of that code and just port it over to something that lives in user land that kind of, you're not even emulating it, right? You're just stubbing out the low level system bindings and then running the logic, which is all you really care about to begin with. So yeah, I was surprised that I had never thought of doing that before Nate Lawson told me to do it. And it's like the equivalent of the WireGuard thing, but for whole system emulation, except that you don't need to emulate anything. You just need to take their C code and port it over.
And expanding on that, just reading the source, always a great trick. And then if you want to be like a real professional like Jason, reading the disassembly, but I am awful at that. And when I had to teach people how to do buffer overflows and the like, I farmed that out and had other people do it.
Well, I think my recorder just crashed, so I think we should wrap it up.
My recorder is still going, thereby
Yay.
making I've won the race.
You win.
All right, well, I guess we can wrap it up on that note and thank everybody for coming out.
We love you all very much.
Thank you for coming to our first annual, maybe we'll do it again, holiday call-in spectacular.
Wait a minute, Thomas, are you cooking anything exciting for the holidays?
The boy is cooking for the holidays. He's doing a goose. He's had it in for geese all year. Every single family meal, he's like, can we do a goose? Can I cook a goose? Can we kill a goose? And so he's acquiring a goose and somehow smoking a goose for us for Christmas. We've raised him well.
That's next level. The goose.
I'll tell him you said that.
The Christmas goose.
We're having a Christmas goose.
So as someone that lives in Chicago, though, are you going to cook that in your basement kitchen or your upstairs kitchen?
It'll be the upstairs kitchen and the on the deck kitchen.
All right. On that note, have a happy holiday, everybody. And there's still time to catch the end of the Tail Greeter Kier Bowl on ESPN2. So go do that.
Thanks, everyone.
Thank you. Happy New Year.